Hi, my name is Jeff. I'm a contributor at dirtyshirt.info, and we've got a project that's cropped up on us here that I wanted to chat a little bit about. I think what we'll do with this project is we'll hit the milestones and stitch the files together so that we have one complete video on this project. But what we have is a leaking water heater. I installed this about 15 years ago, and at that point in time there was no requirement from the city or anything like that, but there is a permitting process that I have to follow now in order to do this. The way it works is you go down to the city, you pay $45 for the permit, they give you your documentation, and they also provide you with a document that tells you what construction requirements are needed for your particular water heater. It includes both gas and electric. This happens to be an electric water heater. It's 240 volt, it's a 50-gallon unit, and the way that that we've run into this problem was yesterday on our street, the city came out and worked on a particular problem with the main. It had a leak, and they dug up the street and repaired that, but what they had to do was turn the water off for that main. And as they turned it on, I think what happened was a lot of air and so forth, a lot of pressure that normally wouldn't be there. It found its weakest link, and one of those links happens to be our water heater. So what began to happen was that it started coming out the top, and it was flowing, and if you look down here, I'm actually standing in a puddle, and that has to be resolved now. So that's the nature of the project that we're going to be working on. Back to the permitting, because of where we're at, where this water heater is actually located is in a garage. Behind me, this wall is a bathroom, beg your pardon, the master bedroom, the bathroom, the living room on this wall, and then an exterior wall over here. And the reason why I mention that is because in the garage, the permitting or the requirements are not nearly as stringent as if they would be if you were inside the house or up in an attic, something of this nature. So if you're doing your unit and you're inside the house or in the attic or something, what normally has to happen is that you have to have a pan that's located down here, and that would have caught all this water that I'm actually standing in. Then there's a connection for an exit pipe where this water would drain out. Now I can do that, but I don't really want to, because what I would have to do is put plumbing on the exterior of the wall, run it over in this direction, and actually punch a hole through the brick into the exterior of the house. I don't want to get into all that. I mean, we got a leak, we can see it here, and what would happen is if the whole thing just let go, it would just drain out the driveway, and that's fine. So we're going to go with that rather than getting into all these other things. We'll meet code. This job will be inspected after I'm done. So I have a really good idea of what that's going to look like when it's completed, and that when the inspector comes out that we're not going to have any problems. I've looked at the documentation very carefully to make sure that we don't have any problems. What I did do as well is I waited until I had a large block of time to do this job. I'm concerned that once we get into it, we're going to have other problems. For example, getting back up to the top and kind of orienting what we have here. This is a cold water inlet. It goes into the unit. The electricity heats the water. It goes through the unit. It comes back out, and it goes back into the house, and that's how we shower and get hot water at all of the fixtures. When we started having this problem, I turned the power off, and I turned off this valve at the top here to stop that fresh water from going in anymore, and it pretty much took care of the leak. What I noticed after I did that was that the valve is leaking. So valves that do not get used very often and you start to muck with them a little bit, they'll leak. So I'm going to have to replace this as well. So, yesterday I went and I got the permit, I bought a new water heater, I did, these things, and then I come back to the project and I find yet again that I have another problem, okay? So this is the electrical line, and we're going to get back to that later, but there's also this, what's called a high pressure valve. And if this thing were just to completely start to malfunction in ways that you probably can't imagine, there's a valve here that will allow pressure to escape from this unit, and it runs through this copper pipe. It runs around the back, and it's just, you can't see it because the water heater's in the way, but it's just running back here, and it exits through here, and this goes to the exterior of the house. So it just vents that, let's say, steam and water to the exterior. What I'm anticipating is that when I put the new one in, I'm going to have to change that in some way. It's not easy to do because you don't have a lot of room, and it's real close to the wall. So this is a copper pipe that's been sweated with solder, a torch and solder. So when you start working close to walls and so forth, you have to be careful you don't catch the house on fire. So this is something I'm gonna have to cope with, and I'll probably need to make another trip to the store to resolve it. I already have to go because I know this valve here needs to be replaced. So I'll wait till I get further into the job and I kind of have a good idea of what I want to pick up while I'm out. So I think that pretty much covers with what I'm going to do. I am going to hook a hose up. One of the first things I do before we get started, again, the water's been turned off, the power is off. I'll check all that because this is a 240 volt system before I actually start messing around with the electrical connections and where they attach inside this box. What I'm going to have to do, because this has 50 gallons of water in it or thereabouts, I'm going to come down to this valve. I'm going to run a hose from this spigot out to the driveway, open it up, and let that 50 gallons drain out to the alley. So that'll get me started, and then we'll when we hit the next milestone, we'll go ahead and take some video of that, or if I run into any problems, which is really common, right? It always happens. That's how it works. So let's look at the new unit that I've purchased here. It's still boxed up, and it's a little bit different than what we've got going back here. As I mentioned, that's a 50-gallon unit. What we decided to do was we wanted to upgrade. We wanted to go to an 80-gallon. A 50-gallon unit runs about $250, plus tax. The 80-gallon runs about $500. So we've got some cost differences in here, but again, we're doing this ourselves, and we're going to save money because we don't have a plumber coming out. So, it's how you look at money and how you spend your money as to whether or not that's a good deal or a bad deal. What I can say is that when I was at the permitting office, I was talking to the lady who was doing my paperwork, and she said, well, we had a unit in the attic, and we had people come out, they did the work for us. I asked her, I said, do you mind if I asked how much it cost? She says, well, it was $1,200. So, that's sort of gives you an idea of what we're talking about here. Right now, we're in for about $600 or so. $500 unit. We've got the permit to deal with, and then we're going to need some other little bits and pieces that I mentioned over at the other unit. So about $600 right now. You can do that for a lot less. There are 30-gallon units. The warranties matter. The warranty on this unit back here is 5 years. The warranty on the new unit is 6. You can buy 12 years, and I think there was even warranties that were extended beyond that. So you pay for that. They're quite a bit more costly. I would like to point out, though, too, is that when I installed the other unit, I wrote the date and when it was installed. And when we first came out to look at the problem, we noticed right off the bat, we did some quick math and realized, whoa, the unit has been here for about 14 years. So it went well beyond the original 5-year warranty, and we got our money's worth out of that unit. So I'm expecting to do the same thing here with this unit, which it being actually a 6-year warranty. I want to get another 15 out of it. So you have to balance these, and we did a lot of talking and discussion about how that was actually going to play out and what we thought the right thing to do was. So that's where we're at. I think what we'll do is we'll go ahead and cut the video. I'll get into the job, we'll hit a milestone, and then we'll pick it up and stitch it all together. Thanks for watching. Okay, we're into the project, and we've removed the old unit. One of the things I discovered when I was taking it out was that when I hooked the hose up to the bottom spigot on the old water heater, not a drop of water came out. And I reasoned that was probably similar to when you drink a soda pop, that you have to let air in to get the liquid out. So what I did was I disconnected the 2 top lines onto the water heater, and sure enough, all the 50 gallons went pouring out. And it worked really well. It took a while. It was time consuming, but I had plenty of other little things to do while the water was draining. A couple of them were that I'm really thinking about redesigning what we have here for a couple of reasons. But before we get into that, let's just talk about the electrical connection that was coming out of the top of the old unit. This was all sitting in water. I didn't realize that until I got some of the coverings and plates off. You can see this is all dirty, and I'll probably just strip this back, but it was sitting in water, and that surprised me the way that was designed. The unit itself, when I pulled it apart, all the insulation inside of it was completely soaked. It had a hot, musty, high humidity type of a feel to everything. So the whole unit was completely soaking wet. What I also noticed too is that when I undid the flex tube, And here's the one for the hot water inlet. It goes on like so. I flipped this over and looked at the connections, and they're completely coming up. They're completely deteriorated. So what I've decided to do is I'm going to add that to the buy list here, and I'm going to replace both. Okay, it may be just a washer that fits in there. I don't know, but I'm thinking that this is probably going to have to be replaced, but I'll find that out when I get over to the hardware store. But really, because this is a compression fitting, I probably don't want to just replace the washers. I'll probably do the whole thing, which is something that we do a lot. We try not to replace just parts. We're trying to fix systems here. We don't want to get and just replace the unit and leave all this old stuff here that's a risk of leaking and so forth. And we of all people, we talk about plumbing on the site a lot, and we've learned that you don't shortcut this stuff. If you do, you're going to have problems, and water causes so many problems for us. So it's better now to take the time to lengthen the job, right, by whatever time period that might be, and get this stuff fixed for forever. That's really what we're gaming for here. While it was draining, I told you I was thinking about some things, and one of them was the replacement of this valve. And you can see here that it's had some water leaking out for some time. To get this off, what I'm going to have to do is heat this up and melt the solder, and then I can pull the valve off. But I'm a do-it-yourselfer. I'm not a professional. I don't do this all the time. And I was thinking, well, I'll just go get the torch and I'll start heating this up. Whoa, stop. This valve is holding the water back into the house right now, right? So if I'd have done that, the water would have come gushing out. So in order to replace this, I have to turn the water off in the house and stop that from occurring before I can do this work. But it's a good illustration of, we're busy with life and so forth, and we're thinking about all these things we've got to do. And I didn't want this to break on me like it's done, but that's the way it works. And just had to stand back for a second and say, what's going to happen if I pull that valve off without having to turn the water off? That's a big problem. So that's definitely one thing that will get handled. And just sort of the way the builder did this is just all weird, and I'm gonna probably do something with that to get it tucked behind the wall the way it's supposed to be, and hopefully strap it some way. I haven't figured that out yet, but we'll see. It's another probably a design change. Moving over to the high pressure outlet, you can see we've got this rigid setup here, and I'm gonna have to change that some way. What I really thought about doing is probably the easiest way is just get rid of it. That's what I would like to do. And I'll take what is the equivalent to this flex hose. I'm going to see when I get to the hardware store, and I want to run that from here over to the other side of the new unit and just sort of have a loop that extends in that manner. But what I'll have to do in order to make that happen is I'll need to solder what is essentially this piece, this threaded piece, coming out of this pipe so that I have something to attach to here. So it's not maybe as easy as it sounds, but this is a detail that has to get worked out. I've done a drawing. I've got a buy list so that I don't forget anything. I'm like everybody else. I go to the hardware store and I pick up 9 of the 10 things that I needed to buy. I get home, I have to go run back. So I'm spending a lot of time here making sure that I know what I want to buy. I will also take on the floor at the home center with my notes. I'm going to take and configure this out, piece by piece out on the floor so I can see it, because I miss things in my head. I've done that before, and I want to make sure that I get everything. So that's our next approach. We'll move this unit into place. Oh, one thing I forgot. As I mentioned before, this is the bathroom, and there's a master bedroom on the other side of this. In previous times, what I've done along this entire wall is caulked underneath where the slab meets the wall, so that we could keep like cold air out and things like that. And also to keep water out. And we noticed that there was a little bit of water seeping through. And what I suspect happened is when I came through here and did that, because the unit was in the way, I couldn't really see what was going on here. So when I laid the caulk, it was actually clear silicone, I couldn't see that if I had completed the job or not. There was just no room. So now that I've got the unit out of here, what I'm going to do is, again, take the time to dry this out because the silicone won't stick. I'm going to mask this off with some masking tape, and I'm going to apply that silicone into here, because I think that's somewhere in here is where it's leaking into the bathroom, and we can just see just a little tiny bit. So if we ever have a flood again or any kind of water, I mean, we have a washing machine out here as well. So there's these scenarios that can come up and really cause some problems, and we just don't want that in the house. So we've got to deal with it now. better to take 2 or 3 hours to get this floor dry so that the caulk sticks and call it done. And I don't have to worry about it again. It's just too costly and too much trouble. So that's where we're at, and I'm going to go ahead with the plans that I discussed. Thanks.